So, hello and a very good evening to you all. So, first of all, thanks a lot, Khan, Andrew, and other organizers for giving us this opportunity to talk about such an exciting topic like Java 9. It's really interesting. I mean, just like all of you, even we are also pretty much excited about Java 9 and we are looking forward to the launch date. I am Deepu Xavier. So, I am from the Java product management team here in India. And together with me, I have Sundar also. So Sundar is from the engineering team. So Sundar, would you like to introduce yourself?
Hello, can you hear me?
Yes. Yes.
Yeah. Hi. I'm Sundar. I joined Sun Microsystems by the year 2000, and I've been with Sun and Oracle for the past 16 years or so. The first Java versions that I fixed bugs were in 1.1.8. So I don't know how many of you. That was called Classic VM in those days. So yeah, right now we are in JDK 9. So glad to meet you all.
Okay. Yeah. Thanks, Sundar. So since we're going to talk about planned features and things which are either being implemented or yet to be implemented, so please consider today's session as an informational in nature, and would suggest not to take any purchasing or business decisions based on what we share today, because the scope and timeline is, I mean, it could change, even though we are not planning any, but it could change. So just as a initial statement. So today, what are we going to talk about? So we'll be talking about primarily Java 9. So Java 9, it's like, if you look at the feature list, it's too huge. So we may not be able to cover the entire feature additions onto Java 9. So what we'll be doing today is we'll be having a quick look on some of the Java 9 interesting features. We will cover some of it in a bit more detail. And the primary release driver, that is a Jigsaw, we will have a deep dive onto that, and that will be done by none other than Sundar. Yep. So first one, timeline. So we've been talking about Java 9 for quite a while. So just look at the screen, you'll be able to find that we are targeting 23rd March 2017, that is next year, for the general availability. But having said that, if you look at the first line, you'll be able to see the feature complete was marked as 26th May, which means most of the features which we have planned for Java 9 is already available, and they are already available in early access. So one point would be like, I am sure some of you, if not all, would have already given a hands on the early access. So people who have tried that would have a better understanding about what is in stock for them or in stock for the developer community in another 1 year or less than 1 year. So if not, I would suggest you to download the early access and then get a feel. So this session, the whole agenda is that it should give you a kind of interest. See, yeah, these are the kind of features that we're gonna get in Java 9. Let me try out and see whether this is meeting my requirement, or if I have any feedback, I should get back to Oracle and say that, or to the OpenJDK community and say that, yeah, I tried it, I have some issue, and this is my feedback. So with this, we can actually drive the ecosystem forward in a positive direction. Now, what are we talking about Java 9? When we talk about Java 9, we're talking about JEPs, that is a JDK enhancement proposal. So in an OpenJDK terminology, a JEP is what gets formed into a feature in Java 9. So when we look at it, we are talking about 84 different JEPs, JDK enhancement proposals in Java 9. And that too in a variety of components like the client library, the serviceability, the core library, the hotspot, tools, 6 JEPs related to Jigsaw, and so on. Now, as I said earlier, in the interest of time, it is practically not possible to cover the entire 84. But if you look at it from a 10,000 feet high, these are the prominent ones which will stand out to any developer. Like first one could be the Jigsaw, where we are trying to implement the modularity into the Java platform, which will ensure that we get a better scalability upward and downward, better security and better maintainability to the Java code that we write and the Java applications that we make. Then we have compact string. This is about improving the footprint, memory footprint of a string, how it is stored, the internal representation of string, and how it will impact your performance of the application and the memory footprint of your application. Then we have the garbage collection being defaulted to G1 GC. So from Java 9, the default garbage collector will be G1. Then you have the multi-release jar file, which will give you the capability to have a single jar file with multiple versions of a given class file. For example, if you have a given class, you can have Java 7 version of the class, Java 8 compatible version of the same class, and Java 9 version of the same class. And depending upon the system where it is running, it will appropriately pick the right or the respective class file and move forward. Then we have the convenient collections handling. This is something which might be interesting to everyone as a developer. The way you create list or map or set is going to be much simpler as compared to how we were doing till date. So we will have a small hands-on demo on that. Then we have a new version string coming up rather than the 1.8.0.65. We will be having something like a neat, semantically clear 9.0.1, 9.0.2, and henceforth. Then again, intern string. You would have seen string.intern since ages, but now again we have an addition on top of that. We are going to have this intern string to be stored in a CDS, a class data sharing concept. We have an HTTP2 compliance related feature addition and stuff like that. So this is just to give you, like, what are we talking about? I mean, these are some of the important, again, reiterating on that, these are just some of the important features that we are expecting or that we can see in the Java 9. So in the interest of this session, what I've done is that I've tried to segregate these features into multiple headings, one of which would be behind the scene improvements. So these are the goodness or the good features that you get just by updating to JDK 9. You don't want to make any change to the code base. You don't want to make any change to the settings or nothing. You just update to JDK 9 and you will get it. Coming back. So one of that goodness that you get is the compact string and intern string in CDS archive. Now, if you look at it, Java has been giving a lot of importance to string class, to string and character array since the beginning. You had string.intern, then we had compressed string, then in Java 8 we had a string deduplication, and now we have something called compact string. So why is it like that? I mean, why do we give a lot of importance to string? The answer is basically very simple. Like when we were doing the analysis on around 950 odd heap dumps, what we analyzed was that around 10 to 45% of the live data, and I'm talking about real live applications, around 10 to 45% of this data, live data, are character array, which is not a small amount, around 10 to 45%. You can imagine it's a huge number, which means the character array and string has to be handled in a proper manner. We can't afford to have any imperfection in that. Just let's take a look at a very harmless, simple Java program where I'm trying to assign to a variable language. I'm assigning Java. As per the old string class, if you look at on the right side, so just a snippet or part of the old string class or the string class that we have now in Java 8, it is internally represented as a character array, which means the Java word will be stored in a character array with 2 bytes consumed by each character, and it will be by default UTF-16 encoded. Now the question is it perfect? Well, it depends on the definition of perfection, right? So if you look at it, perfection is achieved not when there is nothing more to add, but when there is nothing more to take away. Now if you look back on the left side, do you have anything to take away? Yes, the upper bytes. It's a UTF-16 encoded character array, but still if you look at it, the upper byte is 0, practically unused. So what is happening to that 2 bytes? We are wasting 1 byte per character. So then the question was, how can we solve it? We thought probably, yeah, we can actually split it. If it is not using, or if the upper byte is unused, let's not use it. So what we did was that we modified the string class. It's a representational change, so there is no change required from the developer side. Sorry. So if you look at the new string class in Java 9, you will see that instead of a character array, it's a byte array. And we have introduced a new field called coder. It's a byte which will represent whether it is a UTF-16 or whether it is a UTF or a Latin 1. Now, with that change, what has happened is that the logic runs like this. It will just check for the given character array. If all the upper bytes of each character is unused, it will deflate it, it will compress it, and it will change it to a Latin 1 encoded 4-byte character array, byte array in this case. So here, the byte array value will be JAVA, the corresponding hex value for that, and the coder will have a value of Latin 1 encoded. So this looks like a very simple change, but if you look at it, the kind of benefit that we are expecting from this thing is let me skip to the next one. Yeah, we are expecting around 23% reduction in GC frequency, a throughput increase of around 5%, and live data size reduction of around 21%. That is big. Now, but I'm sure some of you might be thinking, now, isn't it an overhead? My application actually have mostly UTF-16s, and why should I ask the JVM to always check and, if possible, compress? I'm sure that it's not going to compress because mine is always UTF-16. So you have a kill switch wherein you can say to the JVM using command line saying that I don't want to do a compact string. I'm happy with my UTF-16, and you can do it if you want. It's your wish. But by default, it will be compact string. Moving ahead. Yep, this is a cool little, very simple thing, but I found it really effective. We have a new Java doc implemented with JDK 9. So before that, let's see Java 8 JDK, the Java doc. So here, I hope you can see my screen, right? Somebody, if you can answer.
Yeah.
Oh, great, thank you. So this is the Java 8 Java doc. Now, assuming that I'm a newbie, I want to create a hash map, and I want to put a value into it. So I want to see the variable, the syntax for that. Just like anybody else, I would do a Control F and put. No, I don't get it. It's all classes. So I would do, yeah, let me just go to hash map, or let me go to map. Yeah, I'll keep on hitting enter until I find a hash map, which just passed. Yep, then I'll click on this. Then I'll come here. I'll have to literally go again, otherwise I'll have to Control F and find it again. So this is how it was happening until now. Let's see how this thing will help us in Java 9 Java doc. You see a simple harmless little search bar here. I'm gonna say map dot put on this plus that. So from a novice perspective, or if you're a developer, I think this is gonna add a little bit of value to your the daily way you're gonna work. Yeah. So I thought, I mean, even it's a very simple thing, I thought I should highlight this to you. As a developer, I think I liked it as a developer. Now, let us look at some of the features or the new tools and capabilities which, as developers, you would really love. Of course, the first one is no-brainer. It's Jigsaw, but I'm not going to cover that. It will be covered in detail by Sundar in another 15 to 20 minutes. The next one is JShell. I'm going to stop sharing for a moment because I just want to see how many of you have actually, if can I have a quick show of hands if you are already comfortable with JShell, just to ensure that I don't cover a topic which you're already aware of. Are you aware of JShell? Okay, 1, 2, 3, 4. Yeah, not, I mean, I think less than 30%, 25%, if my math is correct. Okay, so I'll quickly show you, not in detail, but I'm going back to my screen share. Great. So JShell is nothing but an interactive way of programming in Java. So you might have seen this REPL, read, eval, print, loop in other programming languages. But the difference is that those languages, I'm not trying to generalize, but most of these languages has this REPL or this interactive programming limited to a certain basic set of functionalities. Yeah. But here in JDK, the difference is that this is something written on top of the entire JDK platform. So whatever you can do in JDK can be done on JShell. So rather than talking, I think I should show you that. The first question, how do I use JShell? Let me check what is the version of my Java. It's 9 early access. Is my screen visible? Can you see my command prompt, or should I increase the font size?
Can you increase the font size, please, Deepu?
Okay, sure, I'll do that.
And if you pick, go to like a 36, I think. There it is.
How's it now?
Yeah. Good. Yeah, all good.
Okay, great. So since we see that we have already seen that the Java version that I have is 9 early access, I should be able to just type in JShell, and I should ideally get into the JShell. It's as simple as that. Now, again, the way I look at JShell is that I can have multiple use cases with JShell. One, as a novice developer, as a beginner, I want to see how this math operation works. Simple as it. I just type 1 plus 2. I got answer 3. I wrote 3 by 2, 1. Okay, no, 3 by 2 plot. I got 1.5. So I can understand how Java thinks when I write mathematical operations. This is one way of doing it. Or else, if I want to try out, say, again, assuming that I'm a complete beginner, I'm going to say that I'm writing a new method. String, let me just hide my pop-up. Yeah, I'm going to write string greet as a new method with setting one parameter, name, and I'm going to return the same, return hello. Yeah, method created. Now I want to try, okay, how do I call this? Let me see, greet meljug. Hello meljug. So basically what happened is that it created a method on the fly and it allowed me to execute. So practically what is happening is that I can learn on the go, and any functionality, if I want to explore, I can just try like this. Now, looking at it, okay, I don't want to write hello meljug, I want to write something else. So I will edit, greet, it will open me a little pop-up, console, so that I'm saying hello and yeah, nice meeting you, and accept. So what's going to happen is that if you see here, modified method greet, now I can use this up arrow, down arrow to go to the previous statements. Hello, LJ, nice meeting you. So this is a cool feature. Now again, just to go one level more into it, it's not limited to console-based programming. If I want to do something with Java Swing, for example, I'm going to write import javax dot swing dot star. Imported that, and import java dot. I'm not sure what all are the classes inside, packages inside that. I just click a tab. It will show me all the available ones. Okay, I said awt dot tab. Since there are more than 10, 15, it's a 120. It's asking me, do you want to really see all that 120? I said yes. Here it goes. Let me just take star. That's it. So I imported it. Now I'm going to create a JFrame. F is equal to new J frame. JFrame is created. I'm going to create a J button. B is equal to new J. Click me. Button is created. I'm going to add a button to the frame. Button is added. Now I don't see it. Okay. Now here comes F dot. I don't know how. I mean, as a since I'm trying to learn this, I don't know how I can make the visibility to true. I'm just trying. Maybe it is set visible. Tap. It autocompletes that for me. And if there are more than one, it will give me the suggestions like set. It gives me all the set visible true. Now you can see on the left top. I don't know whether you're able to see that. Let us resize it. F dot set size of say 400, 400. Yeah, I can see that. Right now, even the lambda part. If I look, I want to create add an action listener to the button. B dot add action listener dot out dot ln. Now let's see. So you can do, I mean, it's endless. Whatever you can do in a normal JDK application, you can do it in JShell. So the advantage, to reiterate, as a beginner, you can learn different method, the way you can program. As a developer, if you want to explore different functionalities within a given library, yes, you can add any library to the class path and just proceed from there. Or if you want to incrementally write complex programs, yes, this is a good solution. Next one, convenience factory methods. So let me just again use the same JShell. Let me just say, if as a developer, if I want to create a new set, what I would do is that string set, yes, set is equal to new hash set, okay, and then set dot add a b, or whatever, that's enough. So here, if I list the program, I can see, I mean, just look at the last 16, 17, 18. So it's two verbose. I mean, I just wanted to create a set with two variables, and I end up writing 3 different lines for that in Java. So this created, like, how can we make it better? There are different ways. If you look at this screen, you can see you can use a copy constructor and create a set, again, less single line but verbose. You can use a double brace technique. You can use a stream factory method and collectors. There are different ways of doing it, but I don't think that none of them would be as simple as how we have it in Java 9. String set is equal to set.off a done. This is again a small thing. So basically we have a fixed number of arguments. If it is more than say 10, you'll go varargs and you can proceed from using varargs from there. But for a limited set size of the set, this is going to make your life much easier. Now, yeah, we're on time. So next is a housekeeping kind of thing, like something which is setting up for the future improvements. One is the segmented code cache. So talking about segmented code cache, it's a bit on the JVM side. Like, what is the advantage that you're getting if you segment the code cache? So basically what is happening is that once the code is compiled, you have the different type of codes getting created. You have the non-method code, which is basically nothing but the compiler buffers and the bytecode interpreters. Then you have the profiled code, which has lightly optimized. And then you have the non-profiled code, which has a fully optimized code, but it has a longer lifetime. Now, if you look at it, any program or any Java application is going to have these three different type of code: non-method, profiled, and non-profiled, all with three different lifespan. A non-method will be permanently there. A non-profiled will be there for a longer time, practically permanent, and then profiled code will be there only for a shorter time. And for storing all these three different code, you have just one data structure, one code heap. Yeah, which is not the right thing, because that data structure is optimized for something, and you have three different type of code in that. Which, when a GC is run, when the method sweeper is executed, it sweeps through the entire thing, knowing that the non-method and the non-profile code is not going to change. It's a performance overhead. It's an unnecessary overhead, literally. So what engineers at Oracle they have done is they have created the segmented code cache, wherein the code cache is divided into three. One designated only for non-method, one only for profile, and one for non-profiled code. But still, it is left to your control whether how you want to control the heap size. It can again give a JVM commands and say, I want the heap size for non-method should be this much, for profile should be this much, and so on. So the entire benefit is that the performance from the JVM side, from the GC side, it's going to be improving because of this segmented code cache. And one reason what I think of is that because of the multi-tiered compilation, the amount of code that got generated has increased 2 to 4 times. Because of that, the segmented code cache is really important in Java 9. Again, going forward, we see that we had G1 garbage collector already there for a long time, but this time we feel that G1 has reached a mature state, and we see that there are a lot of advantages because the GC is a low post time GC is G1 over the parallel GC, which is more of throughput oriented. We are talking about a low post garbage collector G1. So we are going to make G1 as the default. So the advantage with G1 as the garbage collector, default garbage collector doesn't sorry, just a second. Sorry for that. So the advantage with making G1 default doesn't only stay on the garbage collection side, but more than that, we see that in version 8, 8.20 to be precise, we had the deduplication. Okay, so
Deepu, we've got some technical difficulties on this end.
Okay, so I think we were talking about G1 as you guys told. What in G1? Okay, yeah. So anyway, I'll repeat it. No worries. So yeah. So from Java 9 onwards, what we're going to do is that we will make G1 garbage collector as the default one. Okay, because it's found to be mature. And we have a lot of, the post time is the most important thing. GC has a very low post time compared to the throughput. We had to compromise on the throughput, but still the overall experience would be much better with the G1 GC. Now again, the thing is that with G1, it's not just about garbage collection. If you look at Java version 8.20, Java introduced string deduplication, which means if I look at this, the string on the left side, Melbourne star, Melbourne city, and Melbourne jug. So these are three different words. But when when JVM looks at it, it finds that yeah, Melbourne is a common word. It's just like string intern, but string intern you have to find what are the repeating words, but string deduplication will do it for you. If I can give you a quick demo of that particular thing, I mean, it's not exactly something related to Java 9, but I can show, if I can show with respect to Java 8. Yeah, so here it's a simple Java program where I'm creating lots and lots and lots of string. Yep. So let's see, and I'm going to run it with a very minimal memory. In the argument, I'm just reducing the memory to say 256. Apply, and let's try what will happen. So what is going to happen is that we will have out of memory in around 20 to 30. Last time when I tried, yeah, it's going to break at 27. So that means, I mean, you created a lot of string with the same survived iteration and with the survived iteration 1, survived iteration 2. So it's a lot of string with the same name. String, so sorry, not survived iteration, string 1, string 2, string 3. Since it's a duplicate and we haven't explicitly set, it is running on Java 8, by the way, not on Java 9. In Java 8, it's going to run like this, and yeah, as we expected, it has thrown out an out of memory. Now let me try to run the same thing on Java 8 itself with use G1GC and use string deduplication. Now this is going to be by default in Java 9. Now here I'm going to run with this parameter, with this arguments, and let's see what will happen. It's going to easily cross the 27 and 30 and 40. Yep. So if you see this, this is the easy difference that you can just stopping it. So it will go on. So which shows that we didn't change anything in the code, but we just changed the GC to G1GC, and we explicitly said use string deduplication, and that did the magic. Yeah. So coming back to the presentation, with this, we're gonna get two advantages. One, the memory utilization will be proper, and we can, with the G1GC, you get a much better system with a lower pause time, and we can get all these advantages of string deduplication and stuff like that. Okay. Okay. Now, moving on. I mean, these are like simple things, but something that you should be aware of. We will be deprecating, not removing. We will be deprecating the applet API in Java 9, which means it will be available but deprecated, and which might be removed in the coming releases like Java 10 or however you want to name it. So the thing is that from a developer perspective, if you're still depending on applets, you will have to consider moving to WebStart or other technology based on that. And it's not because, and the reason why we are moving out is primarily because a lot of the web browsers are moving away from NPAPI plugin, and which naturally makes applet irrelevant. Now, the next one, the process import statements correctly. Rather than explaining again, I would still go back to my NetBeans. It's a Java 8, so I've got two instances of NetBeans opened. This is Java 8, and this is with compatible with the Java 9. It's an early access version of NetBeans. Yeah. So what I'm gonna show here is, let's open the Java 8. I have an interface. Okay. So just let's on a high level we'll cover it. I have an interface here, and I have an outer.java, which has a nested implementation here. Here, what I'm trying to do is, let me just put this import statement below. Immediately you would have, I don't know whether it's visible, but this it's not able to resolve. But if I put this import statement, basically if I reorder the import statement, it went off. So which means that when you look at how an import works, under the hood, the way it works is that it first tries to do a type resolution, and then it tries to do a member resolution. And when it is trying to do the member resolution, in this case, it doesn't identify I mean, let me put it back to an error situation. Yeah, here. It tries to manipulate everything or analyze everything from the pack.outer.nested, wherein it encounters I, but we haven't imported I. It's a simple thing. So it breaks. So I'm sure that as a developer, I have seen this issue multiple times in various scenarios, and I'm sure you also would have seen this. So you would say, okay, let me rearrange the import and give it a try. So in Java 9, if I give the same thing, the same class file, I'm going to put it top or wherever, it will work. Yep. Okay, so the way it has been implemented, or it's corrected, is basically like 3 steps. If you can, I mean, as you see on the right bottom, first we'll be analyzing the import, enclosing imports like the 2 lines that we saw on top. Then the class and the interface hierarchy will be built, but it doesn't look for the type resolution or without any type parameters. Once the class and the interface hierarchy is built, then only the system, the JVM will go for analyzing the class headers and to identify the type parameters. So with this, we know that it will understand, analyze, and it will get a clear picture of the AST, the abstract syntax tree, and it move ahead from there. So this is a clean, it's a neat value add which you'll be getting with Java 9. Now, it's nothing but the features don't have in Java 9. So we have removed the launch time JRE version selection. So if you remember in your archives, in your jar files, you might be having, if you're using this jar file, launch it with this particular version or 1.6 plus, stuff like that. Now that is not going to work. If you are doing from the command line, it will throw an error. But if you are running a jar file with in the metadata, if it is in the manifest, if it is already mentioned, it will not throw an error. It will just throw a warning saying that it won't take into account, and the next time you have to change it whenever you have a revamp of your system. So this is something, but again, the reason why it is being changed is, and it's rarely being used. I mean, it's very, very rare that now people use it. Then we have the JVM TI HProf agent being removed. Again, the reason is that it was not intended to be a production tool in first case. And on top of that, we see that all of the features like the heap dump, the allocation profiler, the CPU profiler, and stuff like that, it can already be done by other Java Visual VM and by Flight Recorder. And you have a whole lot of third-party tools also, which are good. So again, this is a unnecessary overhead to maintain all this. So again, this is not going to impact anyone of you, I'm sure. So just be aware that this is going to be removed in case if at all you are using it. JHat tool is going to be removed. Again, the same reason. It was an experimental tool. It was already documented like that, and it is unsupported as of now. So rather than having an unsupported version in our code base, we are just removing it, and you already have a superior, much superior heap analyzers and visualizers already available. This, okay, some in detail. So what we're going to do is that, so yeah, I think we have some time, 10 minutes more. So what we're going to do is we will go a little bit in detail on some of the JEPs or some of the features. One of the most important thing that you should be aware of as a developer is encapsulating the most internal APIs. Again, not the word most. It's not that we are going to encapsulate all the internal APIs. Before going to this slide, let me go to the next and the next slide. This is a snapshot from 1996 archive of the website from Sun. You can see the logo of Java there at that time. So from 1996, that is 20 years back, it was mentioned that the sun.star packages are not part of the supported public Java interface. So it's not that we didn't know, but as developers, we always tend to use it because it was easy to use. It was meeting our purpose, so we'll use it. Now, coming back, there are two different types of APIs. One, the supported API, and another one is the unsupported JDK internal. So when we say JDK internal, what we mean is it is supposed to be used by Java and not by Java application developers. But we did it. Now the thing is that one question you may have is, how do I know whether I have it? If you're going to remove or deprecate, it's really difficult, right? How do I know it? So let me just show you. So basically in Java 8 and in now Java 9 also we have a tool called JDEPS. JDEPS. So I'll show you how it works. jars. Yeah. Okay. I've got two jar files in this folder. I'm going to run this JDEPS on the second one, the security that's from Glassfish. So I'm going to say JDEPS security jar. So what it will do is it will analyze the entire jar file and it will show me the entire dependency of this particular thing. Now this is a overwhelming thing. The reason being, it analyzed the entire. Let me just try to scroll it to the right. It did a complete analysis on your jar file, and it analyzed where all it has dependency onto other libraries. So if you see, there are references to linkage to internal API, which is bad. There are something called Java base, java.login, which is good, no issues. So practically, it is a bit difficult to understand from this long list, right? So what we have to do is, sorry, instead of JDEPS, I'll say JDEPS-JDK internal, and I'll run it. Now I'll get a small list. Here, what it will do is that it will try to identify only the dependency on your internal. See here, if you see, I think I should. Yeah, here it is trying to find which all classes in the security.jar has dependency onto the internal API, like in this case, sun.security.pkcs, stuff like that. And also will suggest you a replacement. It will show you, yeah, if you are using this internal API, this is a suggested replacement. Yeah, it's a good feature. Now using this, now coming back, using this, you can actually run on your libraries and on your application to understand whether I have any internal API dependency. Yep. So the basic culprits are like sun.misc, sun.unsafe, and all those things are the main culprits that people will be people would have used, which are not supposed to be used. Now, thankfully, with Jigsaw, we can actually control this. Till now, we didn't have an option to control this. If you make it private, the problem or protected or whatever, the problem was that even JDK classes, Sun classes won't be able to, the Java class won't be able to access it outside. But with the module system, Sundar will take you through in a detailed manner, we can actually control this. We can say that this package or this module will be accessible only by this particular party and not by you. Yeah. So based on that, these internal APIs will be controlled. Again, there are two cases in this. There are non-critical APIs wherein we see that there is no evidence of usage outside the JDK. So those things we are encapsulating it without doubt. There are another set of internal APIs where we see that it is difficult to encapsulate completely because there will be people who are using it. And for most of the things, we have already given a replacement in Java 8. But if it is not given in Java 8, and if there is no workaround, or if I wouldn't say workaround, if there is no alternate proper solution, we will be deprecating them in Java 9. And in Java 10, we will remove it. And in the meanwhile, we'll get a solution for that. If you want to control that, you have a command line flag to say you can control your exports based on that, so that you can show that for Java 9 it will work. Yeah. So this is one thing which you should be really looking for. Now let me show you another example of JDK internals and the Jackson jar. Not boy, I mean you don't have anything there. They have no internal dependency. So this is how your output should look like ideally. Yeah. Now I think I'm almost done. A couple of slides more. A multi-release jar file I already covered a little bit in the beginning. So here the thing is that what we are trying to address is there are many situations wherein it's practically very difficult to upgrade to a newer version of Java because your customers, or if you are a library developer, your customers will be on an older version of Java. So the question is, how can I be on an older version, satisfy my old version customer, and still implement using new features of Java? Two solutions: either you maintain two different versions of your library, which is cumbersome, or else you go with the multi-release jar file, wherein you have an option. Like if you see on the right side, on the top, whatever you see is a typical jar file wherein you have A, B, C, D to 4 classes and the meta-int folder. Simple as that. But in the Java 9, what is going to happen is in the meta-int, sorry, you will have multiple folders: 7, 6, 7, 8, 9. For example, we have 8 and 9. In folder 8, you will have A.class, B.class. In folder 9, you have A.class, which means if you are running this jar file in a JDK 9 multi-jar aware system, it will see that, yeah, I see it's a A.class's 9 Java 9 version is there. Let me execute from there. If not, it will run as an old one. Yep. So this is going to make your life much more easier to manage multiple version of class files in a single archive, in a single jar file. Another one, process API update. Before that, here, this is one of the problem that you might have faced n number of times. If you want to run if you want to find the processes, like the current process, let's take a simple example. If you want to find the current process in Windows machine, you will write the code like what you see on the left side, like get runtime.exec and tasklist.exe, and you will do it from there. If you are doing it on a Linux machine, it is again different. It is platform dependent. But in okay, this is the beauty of JShell, right? I mean, every time you can try in JShell rather than writing a main class. Let me open my JShell. So here, what I'm going to do is, let me just scroll to the left. Yeah, I'm going to say that process handle. So I don't know which class has it. I just type a tab. I got it. Process handle. Dot. I don't know what is there. I can see all processes. Yeah, all processes. Dot count. Do they have it? Yeah, count. 158 processes running at this point. Now let me see what is the process ID of what is the current process ID that I'm having. Process H tab dot current 10108. So life is much more easy with the new process API. You have literally a good platform independent implementation of process API. The last one on my part is the new version string. Pretty simple one, but pretty effective, because so far what we had was an older, like syntactically, I mean, from a semantic version perspective, it was not aligning with the industry standard. Like the one which you might be having currently is 1.8.0.103 or 10101. The number goes like that, right? So it doesn't really convey the right meaning to a developer who is new. In the new way, what we would be having is that, like for example, on March 23rd or 2017, we would have the version 9. When we have some critical fixes, like every 3 months we have a critical fix for Java coming out, public version of Java coming out, then the number would be like 9.0.1. When there is a minor release, it will come to 9.1.1. So when you look at the third and the fourth one, 9.1.1, 9.1.2, it's very easy to understand. Yeah, 9.1.2 is the latest version with respect to critical fixes. Like it is the most compliant and most secure version of Java. But if you look at it, 9.0.1 and 9.1.1, from a security standpoint, it's exactly the same. But you will have some minor features got added because the middle one, 0 and 1, this is incremented. So you know that it's a minor release which has happened in between. So the only suggestion that I have to you developers is that in case if your existing code considers that the version is 1.8 dot and you do a use a delimiter of the dot and take the version and you do some manipulation based on that, your code is going to fail. Then you need to consider your code and look how I should read from the new version scheme. Yep. So with that, let me come back to my UI once. Oops. That I am one from my end again as a comment. We haven't covered even, I would say, 10% of what Java 9 is offering. But in the interest of time, I just kept it to some of my personal favorites and some of the things which, as a developer, you might be interested in. Now, either we can have the Q&A now, or else, in the interest of time, since we lost some time in between, do you want to go over to Sundar with a deep dive on Jigsaw?
Yeah, I understand. Yeah, you've got another appointment straight after this. So if you're, you might be actually overdue. So if you don't have time for Q&A, I was thinking that if people had questions about Java 9, put them on the Meetup channel, and then you could go through later on asynchronously and answer them. Yep. I think what we'll do now is just have a quick 5-minute break. But just before we do, before Deepu runs off, quick round of applause. Thanks, Deepu.